So this is the first problem of today's education round, and in this problem we're given that there's an integer n and we need to build a string of uppercase Latin letters such that there are exactly n special characters in the string, and we define special characters as if the character is equal to one of its neighbors, then it is said to be a special character. So let's take this example. So let's say we have something like let's say this is something. So in this is a special character. This won't be special character because it is equals to both of its neighbor. This is a special character because it's equal to this, like its left neighbor. This is not a special character. This is again not a special character. Both of these are special characters and these two are special characters. So like this string has 6 special characters. Now we are given n is less than or equals to 50 and we need to generate or build a string which has exactly n special characters. And if it's not possible, then we should print so. So now, if we look at, if we have just a single character A, like there is no character which is same as this character, and on the right also there is no character which is same as this. So is this a special character? No, right? If we have two A's, then both of these are special character. And now no matter what, if we have, let's say 100 A's in between, we'll have just these two only as special. Is it making sense? Yes, no.
No, why is it that only the last and the first are special? Why can't the
Because, yeah, because in between, like for this, both of its, like it's equal to both of its neighbors. But according to definition, a character should be equal to only one of its neighbors,
okay,
not
either the
both.
left or the right one?
What?
Either the left or
Yes,
the right
either
one.
left or right. Yes, either left or right, not both. So only the first and the last are the special characters. Now, special characters, like can you have just one special character of A? No. Again, like you'll either have 2 or 0 if this is the kind of arrangement. Like either like when first and last character, like this is like there are some characters here, there are some characters here. If I'm looking at this substring, the first and last character will either be both special or none will be special. If you have something like A, B, C, D, right? So one thing is clear, we cannot get odd number of special characters because if you are always getting in multiple of twos, then how can you get odd number of special characters? Is it making sense?
Yes.
What about others? Okay, it's clear. So we can we have like any number of special characters, like let's say even only? So it turns out, yes, we can. Like we can have like this A B A B, like two here, then two more. So if you want 6, you can do this thing. But like that, now there are many ways to do this. You can do something like this also: A B B C C D D, all the way up till you want to go. These are two special characters, two special, two special, two special. And you might think like either like I if what if I went to Z like this Z and after this I cannot go. But if you go up till now, like you actually won't go up till Z because you just want 50 special characters. If you go up till Z, you'll have 26 into 2. 26 is the total number of characters, 52 special characters. So you'll go up at max up till YY. So you can either do it like this or like this: A B B C C or A B. Is it clear? Like these are not just like these are the not only two ways, there are other ways also. So let me show you the implementation. So in this, I have first taken n as input. Then I'm first checking that if n is odd, the answer doesn't exist. Otherwise, I'm like in this, I'm doing A, B, B, C, C. So while my n is more than 0, this answer is my string, final answer. I'm adding this character 2 times. I'm incrementing my character once. And I'm decreasing my n twice. Finally, I can print yes and answer. Is it clear? Or anyone is having any doubt in this? Okay. So let's go to the next problem. So in this problem, we're given that there's an array A of length n, and we can perform the following operation any number of times. Take any element of the array A, which is at least 10, delete it, and insert the digits of that element consisted like element in the same position in the same order. Okay, someone said no. What do you mean? Like, is the last one not clear? Okay, like you got it. So okay, okay. I said, do you have any doubts? So then you should know. Okay, it's so coming back to this problem, we have an array A, and we can break like let's say we can pick any element which is at least 10. Let's say this 45, and we can write it as 4 and 5, like two elements in place of 45. And we can do this operation any number of times, making sure that like we are applying this operations on the elements which are more than or equals to 10. So we finally want to find whether it's possible for us to have the final, like after doing some operations, whether it's possible for us to make a non-decreasing. So if we have something like, so if you have something like this, let's say these are the elements. So see, we can break this into 1, 1, and 2. You cannot break this into 11 and 2, or you cannot break this into 1 and 12. You will break it into like you'll have to write each and every digit. We can break this into 2, 3, 4, and 5. Leave this 6 as it is, 7 as it is. Break this 89 into 8 and 9, and leave this 10. Okay, numbers can only go up till 99. Yes. But the thing is, you get the idea, right? Like numbers can't be this big. But the idea remains same. Like this is how we converted this original array into a non-decreasing array. The values are not decreasing, either they are same or they are increasing. So let's say we have some values. This is a greedy problem. So what we can do initially, let's say we initialize our previous value with 0. This is the previous value. So if the current value is already less than previous, then answer is no. Why? Because after every operation, we are making like instead of 2345, 2345, we have 2 after making a move on this. Like this is true for every number. Like if you break 89 now, instead of 89, you'll have 8. So in a one move, you can only make the number smaller. But if the already like the number which is here is already less than the previous, answer is no. Otherwise, try breaking this down. Why? Because if you can break it at this point, it's always better to break it so that for the next numbers, they don't have to be that big. If the array has to be non-decreasing, eventually all of these numbers should be more than or equals to this number. So if you're able to break this number down, you don't know what these numbers are right now. But if you're able to break this down, if you're able to decrease this, it will be like, it won't make your answer any worse. So you're going in like, either it may be helpful, won't be helpful. Like if you, let's say 11 here, and further down road you have, let's say 100. So you don't have to make this 1 and 1. It's already sorted. But even if you write it as 1 and 1, later on, let's say you have a 99 here. Later on, you just have 99. But at that point also, you can further break this. So if you can break it, so like it's always optimal to break it. Like it won't make your decision worse. So we just have to do two things. Start at initialize initialize your previous with 0, and then just keep checking that whether, if the current element is more than previous, try to break it. If the element is like more than or equals to previous, try to break it. When you are breaking it, you should check two things. First of all, the digits should be non-decreasing, like the order that you're getting for digits. Let's say I have 2, 3, 1. I cannot break this down. I cannot write this as 2, 3, and 1. I cannot write them separately. Why? Because these are not following this order. But if I can break it, then you need to first check this order, that they are following non-decreasing order, and then you should check that this number is also more than or equals to previous, because this is the new number that will come here. Finally, you can update your previous with this thing if you are able to break. Otherwise, update your previous with this thing, 231. So you see why we are breaking in one. If we go, if we break this, we get our previous as 4 for the next operation. So that next element doesn't have to be that big. But otherwise, if you're not breaking it, it will, previous will be 234. So it should be more than 2, more than or equals to 234. So that's why if you're able to break it, break. Is it clear? And if finally, if you see that, okay, you reached the last position and previous is still less than or equals to last number, then yes, the answer exists, otherwise no. Is it clear? Yes, no, anything. Okay, somebody saying I have, like, can you, like, what you can do, you can unmute yourself and ask me. Like, if you write,
Like what I have done, I've like break all the elements till the last element which holds a condition that is greater than AI plus 1.
AI, if AI is more than AI plus
AI
1, you
plus
see.
1.
Okay, so
Like,
you're
yeah.
breaking this. Okay, then,
Like first of all, I iterate all over the elements and I check that the last element which hold this condition.
okay, you're breaking it.
Yeah. So before that, all the elements are like I break.
Okay, and then you moved in previous. Yes, and this should also work. Yes.
Yeah.
Okay, okay, perfect. Somebody said that couldn't get, like, you started, like, if you also started the same way from back, but couldn't get it. Maybe it's because you made some silly mistake, like there is a implementation issue. The idea is correct. B is greedy. Any other doubts? Okay, so let's go to the solution. So in this, I have first taken the array A as input. This is just a digits vector, which I'll use later on. This is my previous, which is initialized to 0, and this is my flag, which is initially 1. That is true. Then I'm iterating through my elements, and if my current element more is less than the previous value, then my answer is simply like it's not possible, and I'll break my loop. Otherwise, I'm calculating the digits, and this is the classic way of calculating. Like I'm also storing this value in a variable called temporal, so that it can be used later. Because while I'm calculating the digits, my current number, that is E, will become 0. So this is the standard way of calculating the digits. I'm making sure that if initially my element E was 0, then I'll insert this digit. Otherwise, my digits will be empty. So then I'm reversing my digits because I've calculated this in reverse order. Finally, I'm checking this thing. If I can break my digits dot front, that is the first digit should be less than previous. Like if the digits is less than previous, then I cannot break. So I'll simply make this previous as the temp. Temp is nothing but the initial value of this number, E. And I'll simply continue. If this is more than, if my digit, like the first value of digit is more than or equals to, then it's possible for me to break. Otherwise, if this is true, it's not possible. So then I'm checking that the digits follow that, like the ith digit is more than or equals to the previous digit, I minus 1. If at some point I find that the ith digit is less than its previous digit, I'll make this check 0. Like I'm checking with this variable and I'll break my loop. So if my check is not true, my previous is temp. Temp is the initial value of the number. Otherwise, my previous is digits dot back. I'm able to break this number. Finally, if f is 1, that is, this was never true, then I'll print yes, otherwise I'll print no. Is it clear? Okay, so let's go to the next. So, okay, somebody has doubts in this. How we are using digits and why are we clearing it? See, a vector, I'm using this vector and it's like declared outside this loop. So if I have declared this vector outside this loop, I need to clear it before computing. Like for the current E, it may have, like it will have previous digits also, previous numbers digit. So I need to make sure that I'm removing them, those digits. Okay, that is answered. And how we are using it? I'm using it here to, first of all, like you don't actually have to calculate it. Like you can do this on the run also, but what I'm doing, I'm checking this that the digits are in non-decreasing order. I'm using it here also that if I can break it, the last digit will be my previous. So these are the two things. Any other thing? Any other doubts other than this? Okay, and these are answered, right? Who asked this? Here we are pushing this. PB is pushback. Is it clear? Okay. So let's go to the next. So in this problem, we are given that there is a grid consisting of 2 rows and n columns. The rows are numbered from 1 to 2 from top to bottom, and the columns are numbered from 1 to n, from left to right. Now each cell contains a row either pointing in left direction or in right direction. And initially there is a robot at cell 1, 1, and the following happens in each move. Firstly, the robot moves either left, right, down, or up. It, of course, cannot go outside the grid, and it also cannot skip the move. Then it moves along the arrow that's placed in the current cell. That is the cell at which it will end up after this move, previous move. And finally, our task is to find whether we can reach cell 2, n from 1, n. So let me explain this. There are two, there is a grid having these two rows. These are the two rows and some n columns. And initially there's a robot which is standing at this point, this cell. So in one move, the robot can either go in left direction, right direction, downwards, or upwards. Now, the thing is, the robot cannot move outside the grid. So these two moves are not allowed. Now, if the robot goes to this cell in like during a move, if the robot goes to this cell, then it will by default move to the next cell because the arrow in this cell is like this. So this is considered one move. Like first robot moves to this cell and then automatically it moves to the next cell. If let's say robots from this cell now move down. Why? Because it can move in any direction, either up, down, left or right, but cannot move outside the grid. So if from here robot decides to go down, then he will be by default sent to this cell. Why? Because the direction of the arrow in this cell is in this direction. So do you understand like what is happening first of all? Okay. So now what we have to do, we need to find whether finally the robot can reach this cell or not. So see in this, the robot can go here, like first move to this cell, then by default it will move to this cell. Then robot can move to this cell. By default, it will be moved to this cell. And from this robot, if robot even moves to this cell, it will be sent back to this cell. So in this, like it will end up ending at this cell. Now, even if robot goes back to this cell, it will be sent to this cell. Now, this is one move only, like he's going to this cell, and by default, it is being sent to this cell. So for this, the answer is no. Is it making sense? So now there are many ways to do this. Like one way is to use DP. Another way is to, like you can also find some pattern. Like there's a pattern, like if you have just check for these alternate, like let's say there are in odd indices of this I, there is this thing, then you cannot. But let's forget about everything. Let's forget about some crazy observation or anything. I'll tell you the simplest solution. The simplest solution is what you can do. Like if you want other solutions also, like I'll discuss those with you maybe after I'm done with the session. Okay, I'll tell you other solutions also in brief. But the easiest solution is there are 2 into n cells, and you can see if you are at this cell, if the robot is at this cell, he already had the chance to make decision where it would like to move. So if you are again going back to this cell, there is no point, right, to visit the cell again. So there are at max 2 into n cells. Once you visit a cell, mark it as visited. And what you can do, there are at max 2 into n cells. You need to just apply, you can say either BFS or DFS. So just apply breadth first search. Like if you don't know what breadth first search is, like don't worry. Like if you're at this point, just move in these two directions. Once you reach this, like you'll be automatically moved to some other cell. So mark this cell as visited. This is also visited. From here, you'll be sent to some other cell. Let's say this. So mark this as visited. Now from these two cells, again start. Like you can go in four directions, four possible directions. Try moving to those and see if whether this cell leads you back to this. So this is already visited, so don't go to that cell again. So this is just a simple BFS problem. And finally, you can see that whether you were able to end up at this place or not. There are at max 2 into n cells. Is it making sense? What about others? Like this is just simple brute force, you can say. So let me show you the implementation. The implementation is very simple. Like it gets clumsy because I just copy pasted the if condition like many times. So let's start from here. See, first I'm taking n as input, then I'm taking string s, like the 2 rows as input. So this is the first row, second row. Then this is my possible. Possible is a 2 into n vector, same like the grid. So if possible of ij is 1, then it means that I'm able to visit that cell. So possible of 0, 0 is initially 1. Now I have implemented this using BFS. So I've used a queue, and my queue is having a pair, IJ basically. So initially I'm at 0, 0. The robot is at 0, 0. So that goes in queue. Then while my queue is having some size, this is now as a typical BFS. So what I'm doing, I'm taking the front value from my queue. This is X comma Y. I'm at X comma Y. I'm removing that from my queue. Now I'm moving in the 4 directions. So if X minus 1 is more than 0, that means the robot can go up. Now if the robot can go up and the direction in which that cell is pointing is right, then eventually the robot will end up at X minus 1, Y plus 1. So I'm checking that that position is not visited, because if that position is already visited, you don't need to go to that position again. Otherwise, you will go to that position, mark it as visited, and insert this thing in your queue. Do the same thing if in X minus 1, the arrow was pointing towards left, and X minus 1, Y minus 1 was not visited. Otherwise, if you are going down, X plus 1 is less than equals to 1, that is, you're not moving outside boundary, and the cell, like the cell is pointing towards right, then you'll end up at X plus 1, Y plus 1. So see that it's not visited. Otherwise, if you're going to X plus 1 and check that the cell that there is pointing towards left, you'll end up at X plus 1, Y minus 1. Similarly, if you're going towards left, check for if it's pointing towards left. And if you're going towards right, check if it's pointing towards right. Why I'm not checking for going towards left and pointing towards right? Because it doesn't make any sense. See, if you're going towards left, let's say, if I'm here and I'm going towards left and the cell here is pointing towards right, I'll end up at this only. So I'm not checking for these things. That going towards left and the sign there is towards right. Otherwise, I'm checking like if I'm going towards left and the sign there is also left, then I'll end up at X, Y minus 2. Otherwise, if I'm going towards right and the sign there is also pointing towards right, then I'll end up at X, Y plus 2. Finally, I just need to check that I was able to reach 2 comma n. That is, if I look at like starting from 0 index, it is 1 comma n minus 1. So if it's possible for me to reach this, I'll print yes, otherwise print no. Is it clear? Like simple BFS. What about others? Yes, basically you'll arrive at all the positions, and from there you are deciding to move in all the feasible directions. But the thing is, there are at max 2 into n positions, like 2 into n cells. So that's why the solution works in linear, big O of n time complexity. Same as BFS. Like you won't visit a cell twice. So let's move to the next. In this problem, we're given that there is a string S consisting of lowercase Latin letters and or question marks. Now, a tandem repeat is a string of even length such that its first half is equals to its second half. So a string A is a substring of B if A can be obtained from B. Okay, this is. Now, our goal is to replace each question mark with some lowercase Latin letters in such a way that the length of the longest substring that is a tandem repeat is maximum possible. So let's see some examples. Let's say if the string doesn't have any question marks, then we just have to calculate what is the longest tandem repeat. So this is the longest tandem repeat because the first half is same as second half. If it was having some question marks, then we should have replaced this with AA. This was B. This is AA, and replace this with B. So these are the replaced. And this way also we would have got a tandem of length 6. So this is what we have to find. Like suppose we are able to replace these question marks. What is the maximum length possible for a tandem? Now again, this can be solved via DP, or like there are other also observations. But let's try to stick to the basics. Like what is the easiest way to solve this problem? Let's say there's a string like this, and you need to check whether this is a tandem repeat or not. So what should be the thing? Like this should be same as this. This should be same as this character, and this should be same as this character, right? These are the three conditions. Yes, no. And if you shift to this thing, like if I shift to one character towards right, let's say now I'm checking that whether this is a tandem repeat or not, then I need to check that this is right. So now check two things. Like let's remove this thing. Let's remove these things. Let's remove this thing. You see, above red line is like the same as below blue line, and the like both of the above red lines is same as below blue lines. Why? Because the tandem length that I was looking for is 6. If this is fixed, I know that this character will be matched to this character only. And like there will be some other character which is in front also, 1, 2, 3, this thing, which will be matched to this. So if I have, like if I'm fixing the length, I know each character to which it will be matched. Yes, no. Like the red was basically for, I think, from here to here. And the blue was from here to here. So then also I'm getting that thing, right? So my point is, if you have fixed the length, the characters that you are matching will be matched to same only. So the thing is, what like how will the tandem length vary? Our tandem length can go from 1 to at max n, like from 2 to n. One length tandem is not possible. So 2 to n, right? It either it can be 2, 4, like it will be even only because it will have two same parts. So even length 2, 4 all the way up till n. So what you can do for each length, we can create like now doing this has like it's like after this point is very simple. Either you can use 2-pointer or you can use prefix sum. Like by prefix sum, what do I mean? Just like let's say this is the string. These are the n positions. 0 means that the previous like let's say 0 means that this character is not same as this thing. Whatever this character will be matched to. 1 means that this character is equals to this character. So this way you can create your prefix sum 1, 1, 0. First calculate this array and then calculate the prefix sum 0, 1, 2, 3, 3, 3, 4, 4, 0, 4, 4, 5, 6. Now if at any point you get the sum as, let's say currently I was looking for 3 length tandem array. So if at any point I'm able to find the sum of any range as 3, like I wanted to find the sum, the tandem length I was looking for is 6. And if you're able to find, this is my length. If for any range you're able to find the sum as length by 2, then your answer is yes, because like you were able to find at least 3 consecutive positions which are able to match to these places, right? So like this is just one of the ways. Okay, let me explain. Like forget about prefix sum. First, create an array. Let's say I'm currently looking for length is equals to 6. Whether it's possible for me to create a tandem of length 6 or not. So what you can do, just match length by 3, like at a length by 2, that is 3. Just match this character with the character which is third next to it. Why? Because if eventually this character will always be matched with this only. Similarly, match this character with this. No matter where you start, like what is your tandem? If your tandem is this, 1, 2, 3, 4, 5, 6, then also this will be matched to this. And if your tandem is this, then also this character will be matched to this only. So that's why just match whether these are same or not. If they are same, write a 1, like let's say it's 1, and if it's not same, it's 0. So we'll have something like this. Now you just need to check in this array if you are having any subarray for which, like any subarray of size length by 2 whose sum is equals to length by 2. Like the sum is equals to length. You just need to check this. Sum is equals to length. This is basically for length by 2, length. This is the length of the subarray and this is the sum. If they are sum, if it's equal, this basically means that you are able to find 3 consecutive positions which can be equals to this part. So basically you are able to find a tandem of length 6. And this is not just for 6, you can do this for 6, 8, 10. And there can be at max, like let's say we are iterating in order of 2. So it is n, like the array will run for over a time complexity of n. And in each we'll run a loop over this. So it's n into n square time complexity. Is that clear? Like forget up, like I am doing it using prefix sum because I want to find sum of any subarray which is equals to, like for which this length is equals to same as length by 2. But eventually what we are doing, we are just finding that for any length by 2 subarray, the sum is also length by 2. Is it clear? And what is this 0, 1? This 0 simply means that this character cannot be made equals to this. This 1 simply means that this can be made to equals to this. Now this means this 1 can either mean that both characters are equal. One of the characters is question mark. Both the characters are question mark. So in those cases, these can be made equal. So let me show you the solution. So this is the solution. I'm first taking string s as input, then I'm calculating its size. Initially, my answer is 0. This is the vals vector that I have said. That val of 0 simply means that it will be, like it can be made equal, otherwise it cannot be made equal. Yes, for every length. Yes. And then for length from 1 till my length is like there my length was tandem length. Like when I was explaining, my length was tandem length. But while writing the code, I chose my length as all this only, this thing. My tandem length will be length into 2. So instead of halving it down, I'm just calculating for length only. Now what I'm doing, this is the previous thing. Like I'm calculating, like initially I'm calculating for every I whether it can be made to this I plus length or not. So either they are equal, or like since I'm using a or condition, I don't have to write when both of them are question mark, because if either even one of them is question mark, then val will be 1, val of I. Otherwise it will be 0 if they cannot be made equal. Then I'm calculating prefix sum. If initially my val of length minus 1, that is the first, this only can be made equals to the next, that is this first. This thing only can be made equal, like this thing. Then I'll simply calculate the answer as answer is maximum of 2 times this thing. Otherwise, I'm checking for this from length. Why didn't I include this also? Because in prefix sum, like my starting is 0. So like if you have to calculate prefix sum of this thing, what will you do? You will take sum of this and subtract the sum of this, right? Sum of I minus sum of, let's say this is, you have to calculate the sum of this from j to I. So you'll write it as sum of I minus sum of j minus 1. So initially, since my array is starting from 0, I cannot write from minus 1. So that's why I calculated this, checked this separately for length minus 1. So this is separately done. Otherwise, I'm just checking that if the sum of this length is same as this, then my answer is this, maximum of answer or 2 times length. Is it clear? By the way, I don't have to take maximum because length is increasing only. So you can also write this like this. it clear? Like this is one of the ways to do this. Clear? Yes, the problem is easy only. You just had to like somehow come up with this thing that if the length is fixed, the characters that you're matching will be same only. Doesn't matter the tandem starts where, ends where. If the current character is coming in the tandem, either it will be getting matched to previous or the next. There are only two possibilities. So I'm currently like mapping this with the next only. Okay, so that's it. And thanks for joining.
Yeah, Ankit, can you just provide with that the DP idea we were talking about
Yes,
for the
yes,
C problem, if you
yes,
are like comfortable?
yes, yes, yes. Just give me a second.